Hello everyone. One, hopefully you can hear us. If you can you please send probably a thumbs up on in the comments. All right. So here we have Alex and Joe who are going to present about machine learning on IBM LinuxOne. So over to you both.
Okay. Let me go ahead and try to share some stuff. Oh, okay, here we go. Slides. Oh, I see. All right. Profile. I guess I should have done this first. All right. Let me upload a file real quick, and then we can show them. Hopefully this won't take too long. I apologize. We didn't realize there was going to be an upload involved here. But hopefully this won't take too long.
Yeah, Joe, and I'm not sure if it's just me, but there seems like some static.
Hold on.
Yeah, even I can hear that.
Okay, hold on.
Static noise, yeah.
Is that better?
Well, it's still there. Shyam, can you, when I speak, can you hear the static too?
I can.
Let me make sure I'm on the right carrier.
Yeah, see, Joe, see if you can mute yourself, then we can check if the static goes. Yeah, that's it, right? Static goes away. So as soon as you, Joe, as you mute yourself, the static noise goes away.
Yeah.
All right, let me. All right. Let me just switch to my microphone. Okay. Is this any better?
Yeah, that's much better. Yeah, it went away. Very good.
Not sure why that was happening, but okay. All right. So here we have the slides uploaded. And let me present. Okay. Oh, good. All right. Now I can see better. All right. So so I'd like to talk a little bit to serve as an introduction for AI on IBM Z, and talk a little bit about some of the interfaces that you'll probably be using during the hackathon, and try to at least give some background as an understanding as to why AI is important to run on the mainframe, and also understand, hopefully a little bit by the time I'm done here, that you can understand why a mainframe is really a very important part of an AI and ML ecosystem for business enterprises. Probably most of us have used a mainframe pretty much every day. If you buy an airline ticket, or you use your credit card, if you make a hotel reservation, or you do any banking, lots of retail places all have on the back end an IBM mainframe that handles all of the transactions. Increasingly, as well, lots of government agencies also use a Z system on the back end, and they do that to use the mainframe as what we often refer to as the system of record. Where is a final accounting of a transaction, an official version of a transaction recorded? And that is on the mainframe, regardless of how many layers of other systems are in between the mainframe and you as the end user. Obviously, most of us will interact with a mainframe through a web-based interface, and there may be several computers that stand between us as a user and the mainframe on the background. But that mainframe is always there, and it is always the system of reference whenever you record a transaction. So if anyone needs to refer to that transaction and say, well, this is a fraudulent transaction, I didn't actually make this, you always go to the mainframe as your system of reference, and you say, if it says it here on this machine, then this is the truth that we understand, right? And then you can work forward from there. Artificial intelligence has in the enterprise been something of a work in progress over the last 5 to 10 years. We are all familiar with artificial intelligence and machine learning and applications through lots of different interfaces and for lots of different purposes, but it's just gaining traction over the last few years in commercial enterprises. And that is really because the application of artificial intelligence and machine learning for corporate purposes, for transactional purposes, has been a little bit of a challenge. What do you actually use AI and ML for in that particular case? Most AI and ML applications that we think of often involve sensing data, right? Whether it's you're trying to understand a piece of audio, or you're trying to analyze a photo, or you're doing something like that. You're taking sensor data and you're trying to make draw some kind of conclusion as to what that sensor is telling you. In the commercial enterprise case, you have numbers and transactions, and you want to look for patterns. And perhaps you want to try to make sense out of that. And that's a bit more challenging of a use case than we've historically had. You're not recognizing handwriting. You're trying to say, I have this pattern of information that's flowing through my enterprise. How do I make sense out of that? How do I see the greater truth in all of this information that's coming through all of my systems? Just now, I think we're getting sort of the really important part of the curve where AI and machine learning applications are really becoming apparent within the enterprise. By next year, nearly half $1 trillion worth of potential cost savings just for the banking sector can be realized. I mean, people are coming to the conclusion that just for the banking sector alone, the opportunity there is huge, right? And the other thing that really catches my eye is that 84% of executives say they can't achieve their goals that are set for them without some kind of AI or machine learning assistance. And why is that? It's because there's so much information. There's such a vast set of inputs coming into the enterprise, and decision makers have to understand what that data means, and they can't do it without an AI or a machine learning assistant. Just a few more statistics here. I mean, the insurance industry, within a few years, probably a quarter of all insurance transactions will be automated, right? And that's all through AI and machine learning. The other financial institutions are looking forward to using and applying AI to enhance efficiency and and reduce their operational costs. And even government agencies see the potential now of AI assisting various kinds of transaction and processing of large volumes of information. Here's just one use case, and it's the first one that comes to mind for most people in a corporate enterprise, and that's the cost of fraud. You see lots of times advertisements for credit card companies that say, if you don't make a charge and you use our card, you're not responsible for it. The credit card company either has to then, if there's a fraudulent transaction, pay for it and just eat the cost of that transaction, or they have to go after the perpetrator and try to recoup, some kind of financial feedback, from that, or some kind of financial reward for that. Even just pursuing that fraudulent transaction, even if they're able to recover finances from that particular fraudulent transaction, it still costs a lot of money to go after someone to resolve the situation, right? And so any place you can apply an AI or an ML tool to go and assist in that, to reduce the exposure to fraudulent transactions, there's a real potential upside from a financial standpoint to making that happen, right? So reducing fraud is a primary use case for the corporate enterprise today. But in addition to that, and not maybe everybody knows this, is that global financial institutions are being held accountable for the people that they talk to. They can't just pretend that, our clients can go off and do whatever they're going to do and use our services for whatever purposes they want. If there's a terrorist organization that's trying to come in and launder money through a bank, the bank has to know and do some due diligence to say, we're not going to allow this kind of activity to happen with our network, with our interfaces. And in some cases, banks can be, and individuals for those banks can be criminally charged. In other words, you need to know who your customer is, and you have to show that you are doing your part to go off and prevent terrorist activities from leveraging legitimate financial institutions, right? So this is also a protective thing as well. The cost of fraud is one major facet. The other one is protecting your enterprise from bad actors who want to come in and leverage your institution for their own financial gain, which often breaks international law, right? And so you have to be prepared to defend yourself that way. And so AI and ML is potentially a large assist in that particular case as well. Real-time insights are becoming more and more important. And by real-time insights, we mean as a transaction is occurring, you need to apply some decision support mechanism that is AI or ML based. 80% of transactions run within a corporate IT shop. They are not within the cloud. They run within a given corporation's data center. And they stay there for good reason, right? That gives that particular enterprise full control over the environment, which they are often required to prove in order to do things like fraud detection and protecting themselves from bad actors. It is the only way to be sure that your environment is truly secure. That transactional data is often referred to as what's called fast data. You need to make a decision within milliseconds and decide, is this transaction going to be allowed or is it not going to be allowed? And that it can't wait to be put out into a batch and examined either by a person or even by an application, say a rules-based application that's sort of out of band. You have to decide at the point of transaction, are we going to allow this or are we not? While 20% of that is fast data today, in the coming years, that is going to become the majority of the transactions that are out there and running, where a decision is needed in an automated fashion, and human intervention or even a distributed intervention is not going to be fast enough to serve the transaction. So there's this concept of data gravity, and it really is one, it's an idea in the AI and ML space that is really held up over time and repeatedly proven that it's true. Data gravity means if your data originates in a given position within your enterprise, that's where your transactions have to run. And a lot of times there's a temptation to migrate in the other direction and say, well, I'm going to take my data and I'm going to move it onto another system or into the cloud because it's more convenient for me to handle my applications there. What happens in those situations then is that the data can't get into that environment quickly enough, or there are data provenance problems where now you have multiple copies of data and you have to ensure the authenticity and the protection of them. And you wind up with more overhead and more difficulty in managing the fidelity and the sort of keeping track of the true system of record in these distributed environments. If your data originates on a system, bring your applications as close to that system as you can get them and run them there. You can reduce then latency and overhead, and you manage things in the most efficient way possible when you follow this approach. Now, I'll try to stay away from, the IBM marketing pitch here, right? I mean, we're in the middle of a hackathon, and there's a lot of good infrastructure that we want to make available to you, and we want to explain how to leverage it. But IBM, the slide is here so that we can show that IBM has a big portfolio of AI and machine learning offerings of different kinds that are intended for different purposes. There's an entire suite and ecosystem of products that are provided by IBM. Many of these products include regular open source AI and machine learning frameworks, libraries, things that you would be familiar with as a data scientist or an application developer, and they are embedded within all of these different offerings. So I won't go into any of these because in the interest of time, and really it's not as relevant to the hackathon as you might think. If you look at it from this point of view, from a software stack, you can start all the way down at the hardware, and as you work your way up, your resources become higher level and more sort of user friendly and more highly integrated. So above the hardware, there's obviously the operating system. Then you've got your math libraries, compilers, and optimizers, which are low-level things that you have access to programmatically as a data scientist. But generally speaking, you're going to be living here for the hackathon purposes, excuse me, at the framework and runtime level. And so we will be providing you this kind of suite. We just want to show this picture, though, to show exactly where this falls within the entire software stack, right? You'll have all the frameworks that you would expect as a data scientist to be available: TensorFlow, PyTorch, perhaps you like scikit-learn or XGBoost or Spark. Any of those are there. There is the Anaconda environment that allows you to go and manage the configuration of these different frameworks and software packages. And then above those come the IBM products, right? But the point is that you can get lost in some presentations that just show you, here's our IBM AI suite. But really underneath that is all of the infrastructure that you as a data scientist would probably be familiar with, right? And so all of these capabilities are available to you, and we'll talk a little bit more about exactly where those are located and how to use them. Let's see, this one, yeah, I was going to skip this slide. We just had, in this past year, our latest generation of the mainframe called IBM Z System 16, integrated with AI acceleration. So we've actually built something like a GPU or an accelerator directly onto our central die, and in every chip that makes up the mainframe, every central processing chip that makes up the mainframe has an integrated accelerator built directly into it, right next to all of the regular compute engines. Okay, and this system had a code name of Telum. It is now officially the Z16, the Z16 machine with the integrated accelerator. Okay, and before this came out, we were talking about the Telum chip with lots of our clients and to the rest of the world to discuss the capabilities of this machine. So let me go on just a little bit further. On-chip acceleration, right? What are some of the numbers that this can achieve? You can go through and score an AI-based decision in the middle of a transaction in the 2 to 4 millisecond range when the system is running 60,000 transactions per second. We've actually worked with customers who are out there doing this today, right? There are enormous volumes of transactions that go through these mainframes every second of every day. And increasingly, they're being integrated more and more with AI scoring during each of those transactions. Now, lots of our customers have in the past only been applying scoring, have actually only scored a subset of the transactions that actually run, just because they don't have the bandwidth or the capability to go and score every single transaction. This gets back to that fraud detection case that I was talking about earlier, where if you can run a scoring decision during every single transaction and become better at fraud detection and prevention, you've now saved yourself an awful lot of money over the same window of time and over the same transaction set. So this is very, very important. Again, this gets back as well to the idea of fast data and data gravity that we talked about before. Here's sort of a different view of that software stack that we're talking about. This is the advantage that the IBM Z System mainframe brings to the entire environment. IBM owns this entire stack from the silicon all the way up through the software at the very top of the stack. All of this, it can be provided by IBM. IBM has expertise in all of this. And yet at the same time, for those interfaces that are important for application developers and data scientists to use, These are all open source interfaces. These are all freely available interfaces that everyone's familiar with, and you're not locked into using a specific technology when developing your applications. What it does do, though, however, is that if you develop a model, say you've developed it even on another platform, you've trained your model, you have the ability to bring that over to the mainframe and optimize it to run in this environment, and then deploy into your commercial enterprise. So it's important to keep the ideas of model development and model deployment into production separate conceptually, so that you can understand when you're using one or the other. The importance of that is that you want to be able to use all of the open interfaces that everyone is familiar with, and that where everyone can speak the same language about how you're going to go off and create your application, how you're going to develop it, how you're going to train it. But when it comes to the issue of deployment, now you have the option of optimizing this so that it can run in real time, in transaction time, and score actually production workloads, rather than slow the whole environment down, or perhaps just sample a transaction stream hoping to catch a fraudulent transaction, rather than going through and examining every single one for fraud. I'll skip this slide as well. This is kind of a high-level pipeline, an overview of a pipeline that that can be employed in AI and machine learning on System Z. As I said before, you have the option of developing your model and training it off-platform on another platform, perhaps even on your laptop if you like. For the purposes of this hackathon, we strongly encourage everyone to do all of their work on the IBM Z machine through the open interfaces that are available. And again, those will be the ones that you're familiar with: TensorFlow and PyTorch and scikit-learn and so on, right? All of that's available directly on the Z system. But as an application developer, what we want to emphasize is that there's freedom to go and use this, use and create models in any way that you want. When it comes time to actually deploy, that's where the optimization for Z can come into play, so that by the time you put this into production, your business application can truly run in real time and do the actual sort of enterprise level scoring that's required for a production environment. Okay, so the real value that we bring with the mainframe platform is over here at deployment time. We provide open and familiar interfaces for anyone who wants to write models and applications, so that they can be developed easily by people who don't have a lot of Z system experience, and then handed over into production and optimized to run in the Z environment. Key to all of this ability to train, as they say, train anywhere and deploy on Z, is a package called the Open Neural Network Exchange, or ONNX. ONNX is a model independent, framework independent representation of an AI model that allows different models from different frameworks like TensorFlow and Keras and PyTorch to all be represented in a framework neutral way. And this is very important because this can be then fed into, if I have it right here, an IBM offering called the IBM Deep Learning Compiler. So you can take models from all of these different types of frameworks here. You can pass them through ONNX into the IBM Deep Learning Compiler. This is where the optimization takes place. And what you get out the other side is a native application that will run directly on IBM Z systems and has those capabilities and qualities of service that allow you to run in and score in the millisecond time frame, rather than perhaps being distributed throughout a network. Okay, and this is where the real advantage comes along. If you're comfortable, if you get comfortable in developing in these environments on IBM Z, then all of this backend stuff here can be handled by people who have a different set of skills, right? Ones who can then handle the optimization steps and the use of the deep learning compiler and then deployed into production. The point is, we'd like you to work here today and for the purposes of this hackathon, become comfortable in this particular environment, but know that there's always the capability to go off, and should you want to run this in an enterprise corporate environment, this is what would happen before it actually executes, in a production environment on Z systems. This one, I'll skip over this one as well. Well, just one more thing, and I'm almost at the end of my time anyhow. At the top level of the stack, I had mentioned there's a lot of IBM offerings. There are a couple of different offerings for DB2 or database integration that allow you to integrate a lot of your capabilities very close to your data through IBM's corporate database, DB2. And there's a lot of details here for anybody who is more interested in this level of integration. We can certainly guide you in the right direction there. I don't think we'll be doing a whole lot of DB2 work here during the hackathon, but just be aware that there are these capabilities here, and that we are actively looking to infuse, as they say, AI and machine learning to all levels of the stack, in database behaviors, in internal optimization of operational work, fraud detection from within the enterprise. You also want to be able to detect bad actors within your organization, because a lot of times, sort of sabotage comes from within, and you want to be able to watch what people are doing in a production environment to make sure that they're not doing anything with bad intent in your enterprise. So just be aware there is a whole suite of things out there, IBM products that allow say a CIO or someone who reports to a CIO and is responsible for ensuring and guaranteeing that the system in the enterprise is well defended against attackers. They're not only considering attackers from outside the enterprise, but also ones from within as well, right? So that you don't wind up hacked by one of your own employees. Okay, so with that, I think I've reached the end of the slides I intended to show, and I get it over to Alex in a reasonable time frame here, right? So hopefully I've left enough time for you.
Yeah, no, absolutely. Yeah, thank you, Joe. Yeah, thank you for this amazing introduction into the AI machine learning and also IBM Z systems and LinuxOne. And I'll take it from here for the second part of our session here, and I will cover the practical part, which means we'll introduce you to the lab environment that we have prepared. Okay, let me share my screen here. All right, hope everyone can see my screen now. Okay, so I'm Alex Asaichi from IBM, and specifically I'm from the IBM Z Systems part of the organization. And for today's event, we have prepared a lab environment that will let you experience AI machine learning on IBM Z Systems platform. And then you will be able to use it and leverage it for the actual hackathon challenge and build your amazing solution on it. And IBM Z and LinuxOne, as Joe already explained, right? These are the modern mainframe technologies, and IBM Z is also known as IBM LinuxOne, and LinuxOne is built for Linux Open World, right? And both you can see are the latest Z16 generation. Both are depicted here on the slide. They're really powerful, but also they look really nice and designed really nicely. So you can see that here, hopefully. The IBM Z and LinuxOne are these days, right? They are all in, and it's a full participant in IBM strategy of hybrid cloud, data, AI, machine learning. And today, you will actually be able to experience it by yourself, firsthand. I'll walk you through how you can get access to the lab environment. And the environment runs on our LinuxOne Community Cloud. And LinuxOne Community Cloud leverages IBM Z systems and LinuxOne machines that are located at Marist. And yeah, I will do the live demo. I'll also be using and showing you how to use the Jupyter notebooks. And we have prepackaged different machine learning libraries in the Jupyter notebooks, which are well known and familiar libraries in Python. So you'll be able to use them as well. Yeah, for the event, we have prepared the environment where, as you can see here, we have the LinuxOne, IBM LinuxOne, the actual hardware server in the back. And then it runs Linux systems. It runs Docker container runtime. And then it runs a Jupyter AI machine learning container with all the machine learning libraries prepackaged. So from your perspective, you will interact with the environment using a web interface. And as you can see here on the left-hand side, we have LinuxOne Community Cloud web interface where you'll be able to register and request your own instance of either Red Hat Enterprise Linux or Ubuntu Linux. And that Linux actually runs on the IBM LinuxOne hardware. And once you get that instance of Linux, you will install a Docker runtime. And then we have a container registry in the LinuxOne Community Cloud Network, private container registry, which hosts an image of the Jupyter AI machine learning container that prepackages the Jupyter IDE, which you will also be, once you deploy Docker and deploy the container, you'll be able to access that through the Jupyter Notebooks web interface, right, over internet. And it comes prepackaged with all the popular machine learning frameworks such as TensorFlow, PyTorch, scikit-learn, Keras, and others. All right. And next, I'll walk you through the steps on how to get access to your own instance, Linux VM, and Jupyter Lab IDE environment in LinuxOne Community Cloud. At first, you will register with LinuxOne Community Cloud, and please make sure to use the event code SacHacks L1CC. The detailed instructions you can find in the GitHub, and you would start with the GitHub for Jupyter Lab ML, which reflects the same steps, document the same steps with more details, as I will walk you through here in this session. There is also another link with more detailed steps on the LinuxOne Community Cloud. So if you need more, let's say, guidance on how to request the Linux instance and how to register and so on, you can also follow the second link, which provide the instructions on LinuxOne Community Cloud and how to create your instances, how to create SSH key or import SSH key and access it, right? So you will register there. You will receive emails, invitation emails, and confirmation emails. Then you'll get to the dashboard web interface of the LinuxOne Community Cloud, and you will create your Ubuntu instance there with SSH key as a second step. After that, you will open a secure shell connection to that instance over internet. So remotely, you will remote into that instance and install Docker runtime. If you're using Mac or Linux as your workstation, you will just use the terminal and type in SSH and -a your key, and then the IP address of your instance. If you are using Windows as your workstation, you will need to download and pre-install the PuTTY SSH client. And then you can refer again this link in GitHub to see the details, how you would set up PuTTY and the create connection, SSH connection, and how you will import the SSH key to be able to connect. So once you are in and connected with your SSH client, you will be remotely on that Linux VM instance, your own Linux instance running on IBM LinuxOne hardware. And that's when you will need to use curl here, this command, to download the script for the Docker runtime. and then just pipe it to the shell so that it executes and install Docker runtime for you. Once it's installed, you will just run some command for permissions. Make sure that you have the Docker group and it has access to the Docker runtime. And you will start the Docker daemon, Docker service, using this command. And after that, you may need to re-log into your bash session just to make sure that all environment variables and permissions populate properly. That will conclude your Docker installation part. And after that, the step 4, you will pull the Docker container from the private registry. So you would log into the Docker registry here on the LinuxOne community cloud network. Create a shared folder, and this folder is needed so that you can pass your, let's say, data files, CSV files, some data JSON files, and other files to the container, because as you know, container runs as an isolated environment. And yeah, we'll create that folder, change permissions so that you are able to exchange files like in and out from the container. And then finally, you will just type this docker run command, which will run your own instance of the JupyterLab container with all the machine learning libraries in there. And as you can see, it will be running on the port 38,888. And it will be named as notebook. And when you run your Docker PS, you will be able to see that container up and running. And yeah, -D ensures that it runs in the background, not in the interactive mode, but because you will not be interacting it through the terminal, right? Once it's up and running, you will be able to point your browser to the JupyterLab web interface and just interact through the web interface. So this step 4, pretty much, once you run it, you will just be logging out of the SSH session and fully switching over to the web interface in JupyterLab IDE to do your hacking and machine learning coding. There is also in this command, as you can see, you're mapping your local shared folder, which was created in the previous step, to the internal of the container, which is the shared folder, which will show up in the JupyterLab IDE. And I will show it in a few seconds, a few minutes, how it will look like in the actual JupyterLab IDE part. And another item to pay attention here is the token. So you can put your token here just to make sure, because it's a public instance on the internet, so you get the public IP address. Yeah, you may want to use a different token here, because this token is what is used to authenticate through the web interface of JupyterLab, which I'll also show you as well. So in the next step, once you complete it with Docker run and the SSH session, in the step 5, you will just type the URL with your IP address and the port 38,888. And the first prompt you will see on the page will be password or token. And that's where you'll use the same token that you provided in the Docker run command, right, to authenticate your own, right? It says your token, but yeah, you basically put in your own secret in here. And after that, you click login button and it will take you to the JupyterLab IDE, right? Which, yeah, looks like a kind of desktop, maybe like VS Code or Eclipse type of environment, but it's actually a web-based IDE with Jupyter notebooks, which would allow you to do the coding. We also prepackaged 2 sample notebooks and some data, and that's before kind of continue with my presentation here. Let me quickly switch to the live demo part. Once you have the container up and running, and you can access it in the browser, and as you can see, this is my instance here, and yeah, I already have my container running. I have my IP address here. You will get yours, right? So each team will get their own instance here. And it comes with some files prepackaged, like there are two Jupyter notebooks. One is the client retention demo, and another one is the digital the digits, handwritten digits classification using TensorFlow for 2 demos. There is also some CSV data included here, which is used in those demo notebooks, and you'll be able to see how it is used, how it is loaded, and then for your own Jupyter notebook, when you're ready to create, you will be able to maybe follow some of the steps that are used in the sample notebooks. The shared folder that I mentioned is showing up here, right? So anything you put inside will show up in this folder, right? So if you need to copy, upload some files, yeah, you will be able to do it using the shell SSH secure copy command, and you'll be able to copy from from your laptop or workstation. You'll be able to copy the data files or Jupyter notebook files from to and from the Jupyter lab container. So everything you want to stay permanent, everything you want to exchange, yeah, you would keep in the shared folder here. Okay, and now let me maybe do a deeper dive into one of the Jupyter notebooks that we have here, and specifically the first notebook is the client retention demo. And as the nature of Jupyter notebooks, you can see like it's a mix of code with some annotations, right? That's very easy to follow. And you can also make changes as you want, as you proceed, right? So this demo, in this demo, we will show how to leverage machine learning functionality on IBM LinuxOne using the data from CSV files. And there are 2 CSV files. One CSV file includes client customer information, like 6,000 rows of customer information. And another CSV file includes 20,000 rows of transactional data. So transactional data is a credit card transactions that those customers are doing. So there are 2 data sets, and we will use pandas data frame to merge those data, right? The client CSV data, and then the transactions, and then we will also use pandas data frame to do some aggregation of the data and some pre-processing of the data. After that, we'll perform exploratory analysis, and it's all included in this notebook. And after that, after the analysis, we'll use the random forest algorithm, scikit-learn library to predict customer churn based on their credit card transaction, based on some demographic data of those customers. Yeah, we'll be able to determine probabilities of customers abandoning their credit cards or keeping their credit cards. Okay, and yeah, I'll do a steps through, but you can actually run all the steps at once. It's easier, I think, to get a full understanding to do the step through. And as you can see, as soon as I click, it shows the step is executed. Sometimes, like you see, it shows 34 here. It means I ran this notebook already before. So the best way would be to go to the kernel menu here, restart and clear the output so that you can start clean rather than rerunning the same code again. Now, as you see, as I run it, it says, okay, that's a step executed as a step number 1. And here we do import of the pandas and NumPy libraries. Next, we will load the data from CSVs to the pandas data frame. As you can see, we're loading transactions, right? And there is a code that prints out the columns. So if I want to experiment and modify something, right, I'll be able to maybe show something else here. Yeah, like for example, I can remove the print and just execute the same step again. And as you can see, if you don't say print, it will just output the print automatically for the last part, right? If I remove the columns here, it will show me what's inside of the data frame, right? And I'm still in the same step. I'm just experimenting. I'm just modifying what's in there, and just to show you that, yeah, you can learn by just tweaking, changing what's in there, and in order to get a feeling and better understanding of what is happening in that specific step. Okay, so we're loading the transactional data, and that's how it looks like in the pandas data frame. The next step is we doing some aggregations and some conversions, right? So like CSV data always loaded as a text, as strings. So you may want to convert some of the strings into integer, and yeah, you may want to convert it to numeric data. Date time, for example, the date of the credit card transaction, right, is loaded as a text. You want to convert it in a date time format so that it's ready to be processed then. You can output again the result after you did all those conversions. The next step is to load the client data. And there are similar steps, with loading, you're using pandas, read CSV, we're setting the index column and typing the client data frame here in the line just outputs it. The next part of the notebook shows you how you will do the aggregate statistics. So it means you need to merge those data into one data set to make it easier to do the exploration and analysis, and to make it easier then to do the machine learning on this data. Okay, the aggregation is done. Some averages per customer are calculated based on transactions, right? So you can imagine there are 20,000 rows of transactions and 6,000 rows of customers. So yeah, in order to make the data balanced, you would have to do some joins and some aggregations, because some customers may have 5 transactions, others may have 100 transactions. So you want to have the balanced data before you can do some analytics there, right? So we aggregated, we show some average transaction amount, average daily volumes, and so on. And next step, we're doing the exploratory analysis, and that's what typically, these steps in these demo notebooks, what we do, we show you how the typical data scientist will do like their journey through some new problem and new data. How will they, which steps they will do, right? So they will pre-process the data, they will do some aggregations, they will do exploratory analysis, because before you can, there are hundreds of machine learning algorithms, and before you can choose the right one, or even like few of the good ones that will help you solve the problem, you need to do some exploration. You need to look into correlations, some dependencies. You need to get like a feeling of the data, right? And that's what you do with the exploratory analysis here. And for that, we're leveraging the matplot lib, which is a library to plot, to visualize the data. Because the best way to look into the data, if you're looking into like 20,000 rows, right? How can you get a feeling of the data? Yeah, the best way is to visualize it. And yeah, we're gonna leverage the matplot lib. Like for example, the first chart we're gonna output here is for the customers and data and transactional data. What's how the two of the columns relate to each other, like the age of the customers and the annual income, right? And this kind of gives us a visual of the data. We're kind of seeing that, yeah, there is probably the higher income in the ages from like 30 to 60 here, right? The lower incomes are maybe here from 20 to 30, and then after 60. Right? The next step is correlations. So there are multiple columns, multiple properties, right, in the data, and we want to see like which of those correlate with each other, right? Because we want to narrow down. We want to only consider the relevant and influential columns. We don't want to consider all other ones. And as you can see here, we're looking into correlations with the churn, because remember, we predicting churn, and that means the churn row here in correlations. You want to see how it correlates with all other columns like gender, age, highest education, annual investments that person does, income, activity, total transactional volumes, and so on, right? All the columns. And since we're looking into churn, we need to see what is the highest negative correlation here. And on this row, you can see that the highest negative correlation is minus 0.37 is with age of the customer. So it means age correlates negatively with churn. And then another one is the activity level. So these are the two, looks like two properties of the interest for us. And that's how that's how we narrow down our focus to these two columns. Okay, next we may want to do some additional um, dissection of the data regarding those two columns. So for example, age, right, one of the columns, we want to see how it uh, relates to the churn. And the orange here is those who did churn, and the blue is who didn't churn. As you can see, depending on the age, yeah, there are more younger people who churn, who abandon their credit card, and there are less older people who abandoned their card. Right? The more older people who kept it and were loyal to the card. Next, yeah, we're gonna do the another type of chart, which is called box plot chart, and this allows us to kind of intersect both columns, the age and activity, with the churn and didn't churn. Right, and again, the orange color here is those who churn, and the blue who didn't churn. Right? And it kind of gives us an idea that the younger people with a lower activity are more likely to churn versus the older people with higher activity are less likely to churn. Right? And that's still, that's still the exploration, that visual exploration of the data that we're doing before we can actually start doing the actual machine learning and modeling. One more visualization, and this is the bean swarm chart here, and bean swarm chart, and we actually looking again into age and activity versus churn, just using the dots, the bees, and kind of trying to see like, okay, where are the more blue dots versus orange dots here. So now as we did the exploration, we identified and we kind of get the feeling of the data, we can start doing the machine learning modeling for it. And yeah, we'll split the data set into training data set and test data set. And then we'll leverage the random forest algorithm from scikit-learn, a popular machine learning library here. Yeah, we'll create, we will prepare the functions, and we'll prepare the data, and we'll do the actual training of the model here in this step. Okay. Yeah, after model is trained, we can actually type it in here, and we can see what is this model. We can modify this column and say something like summary. Okay, maybe this one doesn't have a summary, but yeah, TensorFlow, for example, yeah, you can actually type in summary and you can see the summary of the model. So the random forest classifier that's used. So the model is trained. What additionally we can do, and that's what Joe also mentioned, right? There is an Onyx format which helps you to port your model between different platforms, between different machine learning libraries, right? There are many frameworks of machine learning. There is TensorFlow, there's PyTorch, there is scikit-learn, and yeah, Onyx allows you to export from all of those different frameworks. You can train your model, and then you can export it to Onyx format, and then you can run it on the Onyx runtime independently from which machine learning framework you used originally. So here we just saw an example. Okay, this model will be serialized and saved in the Onyx format. And yeah, that's the file. As you can see here, we're saving it as a customer churn.onyx. And the same file, as you can see here, was just saved seconds ago. It shows up in our file panel here. So that's how our model was saved and exported. If you want to download it, we can just click on it and do the download here. and then we can bring it to another system, another platform, and use it for the actual inferencing. Because the model is trained, it exported, so now it's portable. Okay, so with the training, we actually, next step, we'll be looking into, with the model trained, we'll be looking into how we can use this model, and we can use it, for example, to calculate the business loss based on the customer information, based on their transaction behaviors. We can calculate and predict what will be the either the win or loss in terms of revenue for this or that specific customer. Yep. And here, as you can see, we calculate for each person, we calculate what is the predicted loss, right, for each of those customers just by using our model. We can do the loss by the age group, and yeah, as you can see, the loss is kind of high, really high in the younger age groups here. And this is all like useful analytics and useful modeling for the business, right, for the bank to kind of predict based on the customer information and based on their activities, like whether they heading toward the win or loss for this or that customer. We can do predictive analysis. In this case, we're going to use the PyTorch framework, and we're going to use a logistic regression machine learning, a different one, not the random forest anymore, but logistic regression. And we'll do a similar thing. We'll try to do the predictive analysis using logistic regression. We'll do the training. You can see it runs quickly through different epochs of training. And then, yeah, we can do the churn prediction based on the activity level. And that's one demo notebook we have here. There is another one. I will not go through this for the sake of time, but yeah, you can run it by yourself, and you can look how the TensorFlow is used in this case. There is a data set, sample data set of handwritten digits, and we're using the neural network model, train it, and then use it to predict those, to recognize those handwritten digits, basically convert it into the actual numbers. So 5, 0, 4, right? Those are handwritten. We can leverage a TensorFlow, and we can do the classification of those. Okay, let me get back to my charts. All right, the next here, this provides you the information what different packages we have pre-included in the container. And you can see there is a BentoML, which allows you to serve the model. If you're interested in machine learning operations, right, ML ops, the BentoML is something to look into. There's Flask, there is JSON, XML. We have Keras, we have Matplot library, we have NumPy, Pandas, YAML processing, scikit-learn, SciPy. SnapML is the IBM machine learning library, which is open sourced. So you may also be interested in leveraging that one. There is a TensorFlow. There is a TensorFlow to Onyx format, the conversion. XGBoost. There is PyTorch. So all the libraries plus many more that are familiar per package. So you don't have to worry about installing, downloading them, and so on. If you have some other library, you actually can install it by yourself in the environment, and that's one of the FAQs that we have prepared. So in the GitHub and also in this deck, there is a bunch of frequently asked questions and answers to them. Like some of them also include like how can I install additional my own packages? If there are any problems you face during the steps of registration or accessing the LinuxOne VM, bringing it up, connecting to it, yeah, feel free to cross-check against the frequently asked questions, and you most probably will see the solution there. Okay, we have a good number of questions here and solutions. Yeah, such as if you cannot get the Jupyter Lab container working, you can redeploy it. So you would look into the logs, you will remove the old instance, and then you just use the same Docker run to run it again, right? You can check the list of the files that you uploaded from the Jupyter Notebook itself. You can install the missing packages. You can upload the data using the IDE. That's the easiest way, I would say, to upload the data. But you can also use the SSH, the shell copy to the shared folder that I explained earlier. Yeah, you can look into the images. If you run out of space, you can always clean up, do the cleanup, and then restart. Yeah, you can troubleshoot in case if you have SSH issues. In case of memory errors, you can also check on your Linux instance, Linux VM, like where you are with the memory and how it is used and who is using the memory. Transferring the files, yeah, we have this information here as well. There are some suggestions where you can source the data, right? Because machine learning is all about data. You probably want to start with the good data set or see which data is available, right? When you're kind of thinking of which idea you can use for the project, yeah, think about which data you have, because data will definitely ensure you are on track to succeed. And there is a kaggle.com, there is data.gov. There are different universities actually provide sample free data sets to use. Yeah, there is a lot of medical kind of data provided, like COVID related medical data, mental health, yeah, all can be leveraged. Um, Speaking of judging criteria, so your submissions will be evaluated by our judges, and this will be based on several criteria. And as you can see on the one side of the scale, we're looking into what's the value to community, how practical is your project idea, how creative you are, and how novel it is. On the other side of the scale, we'll be looking into how are you leveraging IBM Z LinuxOne for machine learning, for analytics, for data, and also whether you were actually running it on the lab environment that we prepared for this event, right? So you can leverage it, right? Means you want to show us in your designs, and you want to show us that it's in alignment with the LinuxOne IBM Z. Different values, as Joe mentioned, right? So it's the systems for processing enormous workloads, high volumes of transactions, data intensive workloads, and so on. And low latency inferencing, yeah, all those different aspects. And that's what we'll be looking into, how it aligns with those values of the IBM Z and LinuxOne systems, how your idea aligns with it and how your solution aligns with it. But also we'll be looking if you have the actual Jupyter Notebook running in our lab environment. And it may not be the entire solution running in our lab environment, but even parts of it. Maybe the model you want to run in there, and the other parts could be running somewhere else. But yeah, we want to see that you're actually running, validating your parts of your solution, kind of core key elements of your solution on the actual IBM Z LinuxOne environment. Okay. And this concludes my part of the presentation. Here are the important links you can see on this chart. Yeah, with QR codes, we have the LinuxOne Community Cloud with the event code and instructions. And then we have the virtual machine that you will get, Linux VM instance that you will get, and the Jupyter Lab ML container that you will bring up and use for the hackathon. All right, thank you very much. And yeah, wish you all good luck with your projects and submissions.
Thank you so very much, Alex and Joe, for this great presentation. I think this would have given a good understanding to the participants about how the system works and what we are looking for with regards to the tracks as well. Somebody asked me one question in person, which I wanted to convey. Uh, is there a way we can access all the content about how to get access and like the codes and all on our Discord channel?
Yeah, we'll be sharing the presentation, the decks, right? There are also those GitHub links. So the more detailed, I would say, more detailed instructions are in the GitHub. Yeah, you can follow the steps, detailed steps there in GitHub, and yeah, it covers all steps, including LinuxOne community cloud registration, bringing up your Linux instance, and yeah, running the Jupyter ML container. All is documented, and also the decks. Joe and I, which we presented today, yeah, we'll be sharing them as well in the Discord channel.
Got it. Sounds great. Thank you so very much once again.
Okay.
Have a nice day.
Yeah.
All right,
Good
thank
luck.
you.
All right.
Bye.
Have a nice day, everybody. We have another workshop from Shubhi Nigam about customer-centric product development. The link is on our Discord, so please go there and watch that workshop as well. Thank you.